This is the review for RAT number 3 or RAT 1.2 1.3. Let's get started. So I have a question here, and number 6 says, please convert 2.37 meters to inches. So the first step is always start with the number given. So I go with 2.37 meters. I'll use an abbreviation. And I know that to go to inches, I need a converting factor. The only converting factor I give you is 1 inch is equal to 2.54 centimeters. So I have to be in centimeters first. So the first step is to get rid of meters. And so I put meters on the bottom and I go to centimeters. And I know that a centimeter and a meter differ by 100. How do I know? King Henry died drinking cat milk. This parentheses is where the meter would go, or liter, or gram, or seconds. That's my SI unit. Okay, so I know that from a meter to a centimeter is 2 jumps, or 2 zeros. It's a 10 to 2 difference. It's 100 times. Who gets the smaller number? It's a 1 to 100 ratio. Who gets the 1? Who gets the 100? Well, a meter being more this to the left of centimeter is bigger, so it gets the smaller unit, and the smaller unit gets the larger number. Smaller unit, larger number. Okay, that is something you are held responsible for able to do at this point. However, you could have looked on your reference table. So here I am with your reference tables, and if I scroll down to reference table C, you will see already marked up I have the centi, which is 10 to the negative 2, which is the same thing as 10 to the negative 2, which is the same thing as 0.01. And that, of course, is 0.01 of what? Well, it's a prefix to the units that are given to you in table D. And there's a meter. So centimeter is 0.01 of a meter, or 1/100th of a meter. Okay, if you'd like it that way. So back to our work here. Okay, we know that for every 1 meter is 100 centimeters, and you notice they want it in inches. So my friends in chemistry, I know that I set up the first exchange with meter on the bottom because it cancels, and now I want to get rid of centimeters to get to inches, so I put centimeter on the bottom, and I know inches has to go on top because that's the unit I want. Okay, every 1 inch there's 2.54 centimeters. Okay, so when I calculate, I take 2.37 times 100, divide by 1, times it by 1, and divide by 2.54. I just do that all the way through my calculator. Now you don't have to divide by 1 or times by 1, but it's there. 2.37 times 100, divide by 1 would be the same answer, times 1, same answer, divide by 2.54. And you should get 93.307, whoa, round to 93.3, and of course the unit left standing in all of this is inches. And of course, that is choice B. Make sure when you answer this, when it's not a multiple choice, you include the inches because it will be wrong. If you showed the correct work but got the wrong answer, you'll get partial credit. I need to have it set up like this. If it's set up just like that, you'll get a lot of points back. Okay, so 6 is B. Okay, moving forward. Number 7, now we're going to measure these thermometers. I gave you the hint, measure the top of the meniscus. The reason is, I guess these are mercury thermometers and their meniscus goes upward because they actually repel the glassware. Any case, when you measure, there's 2 things you do. You take all the numbers from the device. On the device we have the 0 and 10, but these calibrations represent numbers too. This is 1, this is 2, this is 3, and this is 4. You don't really have room to put them on the thermometer, so we use lines. So the numbers I'm definite of is 4, but I have to guess in between my lines. I'm always adding a guess, so my guess is going to be that it's right on the line, so I say 4.0. degrees Celsius. That bothers some people. They think, well, why isn't it just 4? If the answer was 4, my friends, then you would not have these calibrations. You would just have 0 and 10. All these calibrations would be missing. And you would have a thermometer that would just miss these calibrations, and your guess, okay, would just be the 4. All right? So again, the number you get from a measuring device tells a story. The 4.0 tells me that the 4 came from the device that we're certain of. Yeah, we're certain of this. It's definitely at least 4. And then we're going to what? Guess this answer. We guess the next what? Space in between. And those two numbers are significant, as we'll see in the next lecture. But those two numbers come. Now, if I was just given this number, I should know the last number is the guess, and the 4 was marked. And I should be able to rewrite this. So the answer is 4.0, choice B. Okay, number 8. Same idea. All numbers on the measurement device, including all calibrations and markings, plus our guess. Well, what am I certain of? I'm certain that this temperature is at least 98. But now I have a guess in between 98 and 99, and I'm going to guess it's about 0.7. Now you might guess 0.6 and 0.8. It's all acceptable because the guesses can be off by a little bit. So in any case, I'm going to say 98.7. These numbers came from the measurement device. This one, the last one, is my guess. But I have to have a guess. So 98.7, there's my answer. 98 would mean that the 90 was on there and I guessed the 8. All right. 98.08 would mean that I'm guessing a 10th. I'm sorry, I'm guessing a 100th. Okay? And we don't have these hundreds marked. Only individual numbers are marked. So this is more precise than it's shown. So this is not correct, E. We can only give a number from the device that actually matches its precision. So 98.7, choice C. All right, moving forward somewhat to number 9. We're going to measure this. What number am I certain of? I'm certain of at least 70. And then my guess in between the last calibration. Well, these are the last calibrations. Not very precise piece of equipment. So I'm going to guess a 7 in here. Not 0.7, 7. Right? Because the next number after 70 is that individual integer. So I think this is 77. So 77. My guess, okay, was in the individual integer, and this my known amount that was on the device is definitely in the tens place. Tens, not tenth. So 77 is my answer here for A. Okay. And then number 10, which we had some issues with in class, was my problem. Okay. Which member is the, and I think I still have the problem here. This is, I'm going to give you the way that I had it written, which is the least precise. Okay, well, if you look at these choices, we should have measured 4.0 here. We should have measured, and of course that's degrees Celsius. Don't forget the units. This is 98.7 degrees Celsius, and we measured this as 77 degrees Celsius. If you look carefully, the one that's the least precise is the one where the guess is in the bigger part of the overall measurement. These measurement devices have guesses that are in the tenths place, which makes both of these the same precision. So these are the most precise because their guesses are in the tenths place. This is the least precise because you're guessing in a larger range of the overall instrument. So thermometer from question 4, choice C, is the answer here. All right, and that's the reason why. So precision measures how well we can reproduce this measurement, and it works the best when the gaps between the markings are the smallest. and they give us the smallest amount of error. This last number, the 0.7 or the 0.0, okay, is where the error comes from. This is a huge number compared to tenths, and again, it will give us a least precise value. Okay, hope that helped.